Hey everybody, we are going to continue with some rotation practice today. I have the rules pasted into this chart. We know that a 90-degree rotation is the same as a 270-degree counterclockwise. So we'd have to convert it to 90 degrees. And we see the rule. We know a 180-degree rotation is the same in either direction. And we know that if we're talking about a 270-degree rotation, they may call it 90-degree clockwise, but they'd have to specify that. We always assume it's counterclockwise unless they tell us specifically that it's clockwise. So we are going to start with this first chart up at the top. They give us a point, and then they have performed, and they want us to perform 3 rotations and see where the point would end up. I'm going to start by writing the rules at the top. A 90-degree rotation, remember we're assuming that they must mean counterclockwise, is negative y x. It means you switch the x and y and you take the opposite of y. 180 degrees, negative x, negative y. You keep them in the same spot, but you make them both negative. 270 degrees would be y, negative x. So you switch x and y and you make the x negative. And whenever I say negative, I mean the same thing as opposite. So if it's originally negative, you're actually making it positive. Let's perform the rotation on problem 1. So on 2-9, a 90-degree rotation means that you have to flip-flop the points. So 9 and 2 will switch. And then whatever was my original y value becomes the opposite. So negative 9, 2 is where it would end up after a 90-degree rotation. For 180 degrees, you keep them in the same spot, but you have to make them both opposites. And for 270 degrees, you flip them, and then whatever was x before, which is 2, has to become the opposite one now. So 2-9 would end up in these 3 different locations if we were to perform the 3 different rotations on it. Can you pause the video and try number 2? Come back when you're ready to go over it. All right, hopefully you're ready to go over it. For 90 degrees, I know I have to flip-flop my x and y. And then whatever was in the y position before becomes the opposite. So instead of negative 5, I actually have positive 5 now. For 180 degrees, I keep them in the same spot, but they both become opposites. So negative 3, positive 5. And then for 270-degree rotation, I have to flip them. And then whatever was in the x spot before becomes the opposite. So negative 5, negative 3. All right, take a moment, pause the video, and fill out the rest of this chart. Hopefully you've paused the video and you filled it out. I'm just going to whip through 2 more rows of answers, just really quickly without explanation, so I don't waste too much of your time. So problem 3, the answers would be negative 2, negative 8, 8, negative 2, and 2, 8. Number 4 would be 8, negative 5, 5, 8. And negative 8, negative 5. Nope, sorry, negative 8, positive 5. All right. So hopefully that helped you check some of your answers. Now let's talk about how we would rotate a shape if they just gave us a figure like this. So the first thing is to really read what rotation they want us to do. Rotate the figure 180 degrees. I'm going to start by writing down the rule. A 180-degree rotation is negative x, negative y. The easiest way to do this is to look at what the coordinates are. I'm going to label each vertex a different letter, A, B, C, D, and I'm going to write down what each of those coordinates are starting as. So A looks to be at 2, and then 1, 2, 3, 4, 5, 2, 5. B is at 1, 2, 3, 4, 5, 6, 7, 5. C is at 7, 2. And D is at 1, 2. Hopefully I counted right. It's hard to do it live on the video. If I didn't, you'll have to forgive me. Now I want to perform the rotation. So I need an A prime, a B prime, a C prime, and a D prime. And I know I'm going to keep these numbers in the same spot, but I'm going to take the opposite of each one. Pause the video, see if you can come up with what the new coordinates should be. So you should have gotten -2, -5, -7, -5, -7, -2, and -1, -2. So we're taking the opposites of all those numbers. Now pause the video and graph that. So let's see where everything would end up. So -2 and then -5. 1, 2, 3, 4, 5. This is where my A prime is. -7, -5. So 2, 3, 4, 5, 6, 7. Right here. That's B prime. C prime is -7, -2. And D prime is -1, -2. All right, hopefully I counted everything correctly. And a 180-degree rotation should be jumping 2 quadrants. So it does make sense. Hopefully I didn't mess up on any of the counting, but that does make sense of where it would be. Notice how the figure is upside down now too. So it doesn't just slide over. It is a rotation as if it were on like the arm of a clock, but going in the opposite direction. See what you can do for the next one. Rotate the figure 90 degrees. Pause the video, come back when you're ready for me to go over it. Okay, hopefully you are ready for me to go over it. So I would start by writing down the rule. The rule for 90 degrees is -yx. And then I would jot down I would label each of these first. So maybe that's my ABC. Maybe you called a different point A. It doesn't matter. So A, B, and C. My original A looks to be at -7, 7. My original B looks to be at -7, 1. And my original C looks to be at -3, 1. Your points may be in a different order than mine. Doesn't matter. So now I'm going to actually perform the rotation. So I know I need to switch them. And I need to take the opposite of whatever was in the Y position before. So my A is going to become -7, -7. But maybe that was your B. I don't know how you labeled it. For B, I need to switch them. And then I need to take the opposite of whatever was in the Y position before. So -1, -7. Last one, switch them, take the opposite of whatever was in the Y position before, -1, -3. So this would be my A prime, B prime, and C prime. Let's graph it. So -7, -7. 1, 2, 3, 4, 5, 6, 7. So that's where I'm thinking my A prime is. B prime was -1, -7. It's over here. And C prime -1, -3. All right, so this is where I am saying my triangle rotated to. And that makes sense. A 90-degree rotation would jump 1 quadrant counterclockwise. And you can kind of see how the relationships change. So for example, if I start at the origin and I go to C, I'm going 1 up and 3 left. So 1 up, 3 left. If I start at the origin and go to C prime, that's going to be too close to the same color. Okay, I'm going 3 down, 1 left. 3 down, 1 left. So you can see how the numbers have changed. It's the same numbers, but they've switched locations and they're going in the opposite directions now. So that's kind of what happens when you rotate something. Okay, so the last two questions on the page are really similar. Pause the video and finish up this page. Okay, hopefully you're ready. I'm not going to go over these in detail because I don't want to waste your time. I am totally estimating where this should be, but a 270-degree rotation would look something like this. Now the points are totally off. I'm just estimating, but this is showing me 1, 2, 3 quadrants, and the shape would kind of be pointed in that direction. So my coordinates will not be correct because I guessed, but that's approximately where your shape should have ended up. And on this last one, interestingly, it actually just ends up in the exact same spot, because if you rotate a rectangle around its center, it just ends up exactly the same. So that's kind of interesting. On the next page, I'm not going to do this page along with you, but I do want to point out a couple of things in the instructions. So on this page, they're trying to trick you a couple of times. They say, rotate the shape 270 degrees clockwise. With clockwise, none of our rules are going to work. So you have to convert that to the counterclockwise rotation. So let's see what is the same as 270 degrees clockwise. 270 degrees clockwise is actually a 90-degree rotation. So what we're doing here is a 90-degree rotation. And then we have the rule for it. So the first thing I would do on a problem like this is say, nope, this is actually a 90-degree rotation. And then I would write down the rule. The rule for a 90-degree rotation is negative y